Hello, mic testing. Hello, hello. Yes, it's working fine. Now we'll start. Okay, students. In the last class, we have discussed the integrals and some standard types of integrals and methods of integration. How to find methods of integration? We have discussed the method of substitution to find integration. And in this chapter, in this session, we will continue discussing the other problems. Next, different types of integrals. Integrals of some special types of functions. Okay. When integral is of the type, some linear function in numerator divided by quadratic in denominator. When integral is of the type linear in numerator divided by quadratic in denominator, then what we'll do? How to integrate? We will write this as numerator as some constant into differentiation of denominator plus another constant. Because when we differentiate a quadratic, it will be in terms of linear. X square differentiation will be x, so it will always be a linear. That means we can write this linear as some constant into differentiation of denominator. This term will be a linear term plus another constant. Now we'll discuss this with a problem. Why do we do this? Remember, this is for the type linear by quadratic. Okay, first question is integral of x plus 1 divided by x square plus 3x plus 12 into dx. X plus 1 divided by x square plus 3x plus 12 into dx. Now how to find this integral? What we need to do, first step is express numerator as a into differentiation of denominator plus another constant, which means we will write x plus 1 is the numerator, x plus 1 is equal to a into what is the differentiation of denominator, that is 2x plus 3, a into 2x plus 3 plus another constant b. Next, what we need to do, compare coefficient of x as well as constant on both sides. Then we will get here coefficient of x is 2 times a, there is no other x term. Here coefficient of x is 1, which means 2a will be equal to 1 or a is equal to 1 by 2, half. Okay, now we got the value of a, which means when you substitute a equal to 1 by 2, we will get 3 by 2 as the constant here, plus b. This value should be equal to 1. From this, find the value of b, which means what is b? b is equal to 1 minus 3 by 2, that is minus 1 by 2. So now we got values of a and b. Next, how to do? Okay, so we will write this integral as I is equal to integral of a into, that is half into a into differentiation of denominator, that is 2x plus 3 plus b, that is minus half, divided by this term denominator x square plus 3x plus 12. Now what we need to do? Split this into two separate integrals, and in both the integrals 1 by 2 is common, so we can take it outside. This will be 1 by 2 of integral of 2x plus 3 divided by x square plus 3x plus 12 dx minus of 1 divided by 2 is already outside, so we will get x square plus 3x plus 12 dx integral. Okay, now how to evaluate this? Half of this is, if we take this function as t, its differentiation is dt, that is in numerator. That means this is of the form dt by t. So what is the answer? If this function is t, numerator is dt. So this function is of the form dt by t, answer is log t. So we will get first function value is log of modulus denominator, that is x square plus 3x plus 12. Okay sir, now how to evaluate the second one? Second integral is again simple. We already know dx by quadratic. How to convert this into standard form? We have already discussed. Dx by x square minus a square minus x square plus a square. We already know the formulas for this. So we need to write this in terms of standard form. That means again we will have integral of dx by, what is the form we will get? X plus, first we need to write this in terms of square, perfect square. So we will get x plus, divide the coefficient of x divided by 2 whole square plus 12 minus remaining square of constant, that is 9 by 4. So that means this will be equal to half of a log mod x square plus 3x plus 12 minus integral of dx by x plus 3 by 2 whole square. This will be 12 fours are 48 minus 9, 39. So this will be root 39 by 2 whole square. Okay. Next, this is of the form, second integral is of the form dx by x square plus a square. What is the answer for this? 1 by a tan inverse x by a. So first integral will be as it is, minus of, for second integral we will get 1 by a, that is 1 by a will be reciprocal of this, that will be 2 by root 39 into tan inverse of x by a, that is x plus 3 by 2 divided by root 39 by 2. So it will become into 2 plus constant. So now multiply by half, we will get 1 by 2 log modulus x square plus 3x plus 12 minus of half into 2 will get cancelled out. We will get 1 by root 39 into tan inverse of, again 2 will get multiplied, so we will get 2x plus 3 divided by root of 39 plus c. That is it. So why do we do this? First, split this term into two separate integrals by using the substitution or the condition that we can write the numerator in terms of denominator differentiation. Then the first integral will be very simple and the second integral will be converted into standard form. So we can already easily integrate both these values. That's why we do this substitution, right? Not substitution, just manipulation of the term numerator. Okay, this is the value, final answer. Half into log modulus x square plus 3x plus 12 minus 1 by root 39 tan inverse 2x plus 3 by root 39 plus c. Now we will see the solution. So what we need to do first, write the numerator as some constant into differentiation of denominator plus b, another constant. From that we can find the value of a and b. a is equal to 1 by 2 and b is equal to minus 1 by 2. Now what we need to do? Use this value and write the integral and split into separate integrals. Now we will write the integral and split this integral into two separate integrals. And this is of the form f dash of x by f of x dt by t. Here this can be converted into standard form. So answer is 1 by 2 log of x square plus 3x plus 12. Again we will write this in terms of square. So it gets converted into the form of dx by x square plus a square. We already know the formula for this. 1 by a tan inverse x by a. So by using this we can write the final answer. Final answer is 1 by 2 log of this value minus 1 by root 39 tan inverse 2x plus 3 by root 39. Next, second type is, again integral is of the form, some numerator is in linear term, denominator is square root of quadratic term. Again for this type also we will make the same substitution or same manipulation. What is that? First we will write numerator as some constant into denominator differentiation, where denominator is, we will take this value differentiation plus b, not the entire denominator. We will only consider the value inside the square root. So this will be differentiation of denominator that is in numerator. So this is how we will make the substitution for this. Okay. So what we will do? Take the numerator equal to some constant into differentiation of whatever value, the quadratic term inside the denominator plus b. Now we'll see the solution of solve this problem. So what is this? 2x plus 5 by square root of x square minus 2x plus 10. This is of the form linear by root of quadratic. Then we have to differentiate the quadratic and make it come into numerator. So how to do that? We should write this as 2x plus 5 is equal to some constant into differentiation of denominator is 2x minus 2 plus b. Next, what is the step? Compare the coefficient of a and b. Then we should get 2a value should be 2. Here 2x is there, 2ax is there. So 2ax equal to 2x. That means 2a equal to 2, which means a will be 1. Similarly, when a is equal to 1, we get minus 2 plus b equal to 5, which means b is equal to 7. So now we get a and b values. That means integral will become integral of 1 into 2x minus 2 plus 7 divided by denominator square root of x square minus 2x plus 10 dx. Okay. Now how to solve this? Split into two separate integrals. That will be integral of 2x minus 2 divided by square root of this value x square minus 2x plus 10 plus 7 divided by square root of x square minus 2x plus 10 dx. Okay. Now we can find the value of integrals. I is equal to, now if we take this value as t, then its differentiation is in numerator. That means this will be dt. This term will be dt. That means this integration, first integration is of the form dt by root t. And what is the value of that? We already know the standard integral forms. In the first session, basic formulas, dt by root t. Dx by root x integration is 2 root x. So here dt by root t means 2 root t. Okay, so what we will get? 2 root this value. And for the second integral, so for the first integral we will get 2 root this term, whatever is inside, that will be x square minus 2x plus 10 plus integral of second term plus 7 times integral of second term will be dx by square root of quadratic, that is x square minus 2x plus 10, x square minus 2x plus 10. Okay, sir. Now what we need to do? Right, first term will be as it is. We have already integrated this. 2 times root of denominator plus 7 into, this can be written as dx by square root of, right, in terms of square, dx by x square minus a square minus x square plus a square. We already know the formulas for these integrals, so we will write this in terms of perfect square. What will we get? This is x. First write this term as it is, x minus divide by 2, that will be 1 minus 1 whole square. That means we are adding 1 here, remaining will be 9, that is 3 square. Okay, now this integral is of the form dx by square root of x square plus a square. What is the formula? It is in denominator we have square root of x square term, that means it is x, dx by x term means answer should be in log. So what is the answer, students? First term will be as it is, x square minus 2x plus 10 plus 7 times of, answer for this integral will be log mod x plus root of x square plus a square, that will be x minus 1 plus root of x square plus a square will be this value, x square minus 2x plus 10 plus c. That is it. So this is the answer. Is it clear, students, how to solve easy questions? Now we'll see the solution. So first step is to write numerator in terms of a into differentiation of the term inside the denominator, square root and plus b. So here 2x plus 5 is equal to this, compare the coefficient and find the value of a and b. A comes out to be 1 and b is 7. Next we have to write this integral in terms of that value we have found. Numerator should be expressed as given, and then what we need to do, split into separate integrals, and first integral is of the form dt by root t, that is 2 root t, and second integral is of the form dx by x square plus a square, root of x square plus a square. So what is the integral value for this? Plus 7 into log of x plus square root of x square plus a square, that is here in place of x we have x minus 1, so it is x minus 1 plus square root of this value we have already found, x square minus 2x plus 10. Okay, that is it. Easy questions. This is how we should solve problems of this type. Depending on the value we get here, it will be converted into, the second integral will be converted into standard forms. We already know dx by x square plus a square, x square minus a square minus x square. Similarly, dx by square root of x square plus a square minus a square minus x square. We know the formulas for this. The second integral will be converted into such form, and the first integral will be direct, dt by root t or dt by t. Answer will be log t or 2 root t. That is it. It is easy. Next is integration by parts. Okay, what is integration by parts? Before we have discussed what is the method of substitution for integration. And substitution method is nothing but the reverse process of chain rule of differentiation. And here integration by parts is nothing but the reverse process of product rule of differentiation. That means when we have two product of two functions, how to integrate. That is the meaning of it. So here we have integral of f of x into g of x. Let's take this as first function in second function. That's how it will be given in your CBSE textbook, NCERT book. So here integral of first function into second function dx is equal to, first we will write the first function as it is, f of x into integral of second function, that is integral of g of x dx, minus integral of differential of first function, that is f dash of x, into integral of second, that is integral g of x dx. So what is the formula, students? Integral of first function into second function is equal to first function into integral of second function minus integral of differentiation of first function into integration of second function. That is it. So this formula looks very big and it could confuse a lot of students. I will simplify this and give in a short way. If u and v are two functions, remember it this way. Integral u dv is equal to uv minus integral v du, where u is the first function, dv is the second function. U dv, integral of u dv, that is equal to u into v, means we have to integrate dv. Integral dv is v, we already know that integral dv is v, and here minus integral of v is again integrated value into du. Du means differentiation of u. That is it. Easy. So what is the formula? Integral u dv is equal to uv minus integral v du. So you can remember it for writing in your exams. Prefer this formula, first one. But for remembering or solving problems, suppose if there is one more question you need to attend, then you can use this method. For competitive exams, you can use this method. So you should remember this formula as well as this. Right? Okay. Now how to choose the first function and second function? That is chosen based on this order. So that means first function is u, second function is dv. That is the formula. Right? U dv, integral u dv. That means which function should be chosen as u and which should be chosen as v. We have two functions, we can choose any one. So how to choose? That is given by this table. You should remember it as ILATE. ILATE, you should choose the first function in the order of this ILATE, where I means inverse functions and L means log, A means algebraic, T means trigonometry, and E means exponential. That means suppose the product of two functions are, say, x into sin x. That means x is the algebraic term, so this is algebra. Second is sin x. That means T is sin x. That means we will choose the first function u f of x as algebraic function x and dv as second trigonometric function sin x. Is that clear, students? That is how we should choose. So whichever comes first in this order, choose that as the first function and the other function will be second function, that is dv. So in integration by parts, we will choose the first function in the following order. And this is not always applicable. Mostly it is applicable, but whenever we have indefinite times of integral values, this integration does not stop at any point. There are functions like that. Exponential function will never end. Trigonometric function will never end. In those cases, you can choose any one of this function as the first function. But other than that, most of the time, we will choose first function in this order. So that will be this given by this table. Right? Next is, question is integral of x into e power x. Okay. Now I will write in the notation that I have given. U first function is, what is the first function? Here we have algebra. This is algebraic, and exponential. So that means I late is the rule. I late is the rule. Which comes first? Algebra comes first and then exponential. That means algebraic function x will be taken as first function and exponential function will be dx, e power x dx. Remaining term is, this term is dv. Right up. So this is u is taken as x and dv is taken as e power x. Then what we need to find? Du. What is du? Du is equal to differentiation of this du by dx is 1. That means du will be equal to dx. And what about integral of dv? Integral dv is v. That is equal to e power x. Integral dv is integral of e power x dx. That is e power x itself. That means final, what is the formula? U into dv integral, that is equal to u into v minus integral of v into du. Now that is given by integral of u into dv is given question x into e power x dx, that is equal to u into v. What is u? X, write it as it is, into dv into v. V is e power x. V is e power x minus integral of v again e power x du, that is dx. Du is dx. So final answer is x into e power x minus, this is integral e power x is e power x plus constant. That is it. So we can write this as e power x into x minus 1 plus constant of integration. Finished. But for solving in your board exams, you should take this function as f of x and g of x. Integral dv means v, that is integral of g of x. Here it will be f dash of x. So that is how we should solve this. Right? This is the simpler notation for understanding. You can use this in your board exams. Sorry, in competitive exams. Now we will see the solution. Again, first function will be taken as u, second function is v. So x into integral e power x dx minus integral of differentiation of first function into integration of second function. So you should remember it like this. X is u into integral of this function v minus integral of differentiation of first function into integration of second function. So final answer is x into e power x minus e power x plus c. E power x into x minus 1 plus c. Next question is integral of x square cos x. Integral x square cos x dx. Okay, now again this is first function is algebraic, second function is trigonometric. So how to choose first and second function? We will choose first function as algebraic Eilert rule. Which comes first? Algebraic comes first and then trigonometric function. So that means f of x or u function is taken as x square and dv is taken as remaining value, that is cos x dx. Now from this, what is the value of du? Du is equal to 2x dx. And what is dv? Integral is v, which means v is equal to integral of dv, that is equal to integral of cos x is sin x. Now what is the formula? Integral of u dv is equal to u into v minus integral of v into du. Now that is equal to integral, question is equal to I is equal to u into v, that is x square into v is sin x, x square into sin x minus integral of v into du. V is sin x into du is 2x dx into 2x dx. Okay, this is equal to x square sin x minus 2 times of integral of x sin x dx. Now again, this is a product of two functions, so we need to apply the same formula, integration by parts again. Now for this function, let's take this as I1. For I1, let's do it in another color. What is the u? U is, again, this is algebra and trigonometry, so u is equal to x, du will be equal to dx, v is equal to dv is equal to remaining sin x dx, sin x dx, sin x dx, which means v will be equal to integral of sin x, that is minus cos x, minus cos x. So then what we get? I1 is equal to, I1 will be equal to u into v, that is minus x cos x, minus x cos x, u into v, minus of integral of v into du. V is minus cos x into du is dx. So here minus will get cancelled out. This will be equal to x cos x minus x cos x plus integral cos x is sin x plus sin x plus c. So what is the final answer? I will be equal to, I is equal to, first value is x square sin x minus 2 times of this I1 is minus x cos x plus sin x plus constant. So what is the value, students? X square sin x, final answer is x square into sin x minus, this minus into minus will become plus, so we will get plus 2x cos x plus 2x cos x minus 2 sin x plus constant. Clear now? This is how we will solve for integration by parts. First what we need to do, here x square cos x. So first choose the first function and the second function. How to identify that? First function, choose this in order. So here algebraic function comes first, so take x square first, and then that is the u function, and the other function will be dv. So now we can solve this. Clear? So final answer is x square sin x plus 2x cos x minus 2 sin x. So suppose if there is x cube, then we need to find this, use this procedure 3 times, and then again finally compile the answer. Clear now? So this is how we will solve this. So x square sin x minus integral of this. Again, we already know how to solve this. Take f of x and f dash of x, find f dash of x. Similarly, g of x, integral g of x. Finally, find the answer, u dv. So answer is x square sin x plus 2x cos x minus 2 sin x plus c. Procedure is same. We have to apply this integration by parts 2 times. Next question is x into sin square x. Okay, sir. If we choose this function as u and this function as v, that means we need to integrate sin square x. We don't know the integration of that. There is no direct formula for integration of sin square. Then can we interchange this? Take this function as u, we can differentiate this function as v. Then if we do that, then integral of this dv will become v, that will be x square by 2. Again we have to integrate that, so it will be a continuous unending integral. So actually we need to reduce this power into simpler terms by using appropriate formula. That is how we should solve this question. So what is the formula for sin square x? We already know that. We know that sin square x, 2 sin square x is 1 minus cos x. So we will get 1 minus cos x divided by 2. Now we will use the proper formula for this, which means integral is equal to integral of x into 1 minus cos x by 2. We can take out 1 by 2 outside. This is equal to 1 by 2 of integral of x. We can split this separately, minus integral of x cos x. Okay, now we can apply the integration by parts for the second function dx. Okay, now we can apply integration by parts for the second value. So what is the first integration? That is integral x is x square by 2. So we will get that is equal to 1 by 2 into x square by 2 into x square by 2 minus of 1 by 2 into integral of x cos x dx. Okay, now let's take this value as I1. Now what is u and v? U is, again this is algebra and trigonometry, so we will take the algebra as u equal to x, du will be dx, v function is, dv function is cos x dx, which means v is equal to integral cos x, that is sin x. Next, what we need to do? Use find I1. I1 is equal to u into v, that is u is x, into v, that is sin x, x into sin x, minus integral of v is sin x into du, that is dx. That is equal to x into sin x, integral sin is minus cos, so we will get plus cos x. We can add constant here, or we can also finally add the constant. So that means, what is I? I will be equal to half into x square by 2, that is x square by 4, x square by 4 minus 1 by 2 times of integral x cos x, that will be x sin x plus cos x, x sin x plus cos x plus constant of integration. That is it. Easy. Clear now how to do integration by parts questions. So we have to first identify which is the first function and second function, which function is u and which function is dv, and then use the formula and substitute. That is it. Easy. Now we will see the solution. So what we need to do? First, convert this sin square x into simpler terms and then integrate. Okay, this is 1 minus cos 2x by 2. So finally we will divide this. Find the integral of separate terms. So 1 by 2 into x square by 2 minus of x into integral of second function, that is sin 2x by 2, minus integral of first function is x, that is 1, differentiation of x is 1 into integral of second, that is sin 2x by 2 plus c. So final answer is comes out to be this. Okay, next, this is a standard result. This result is obtained from integration by parts. I will directly give the result and we will see in alternate terms what is meant. I will explain in a second. Function is of the type e power x into f of x plus f dash of x. Dx. Integral is of the type this e power x into f of x plus f dash of x dx. First, we will consider what is the differentiation of e power x into f of x. That will be equal to, this is a product of two functions, so we will get e power x into first function into differentiation of second function, that is f dash of x, plus Keep the second function as it is, f of x into differentiation of first function, that is e power x. So this is nothing but e power x into f of x plus f dash of x plus f dash of x. So that means when you have to integrate this, that will be answer is e power x into f of x. Integral of this function is equal to integral of differentiation of e power x f of x. Integral differential will get cancelled, so we will get e power x into f of x. So this final answer is e power x into f of x. You should remember this result, students. E power x into f of x plus c. Okay. So now we will see this question. Here e power x into sin x plus cos x dx. That means e power x into identify the function. So it is in the form of f of x plus f dash of x. So what is f of x? We can choose if f of x is sin x, its differentiation is cos x. So that means this is f of x. Sin x is f of x and cos x is f dash of x. That means final answer is e power x into f of x. So that means e power x into sin x plus c. That will be the answer. Easy. So let's take this function as f of x, another is f dash of x. This result is obtained if you have to integrate this actually, then we will use integration by parts to derive the result. Right? So instead of doing that, it will be easier to differentiate this function. So final answer is e power x into f of x. That is e power x into sin x plus c. E power x into f of x is the answer. So e power x into sin x plus c. Next question is integral of log x. This is a very important question, students. Integral of log x. You should remember it as a result for competitive exams also. So what is integral of log x? We know integral of 1 by x is log x. Differentiation of log x is 1 by x. But integral of log x, what is that? First, what we need to do for this is identify u and v functions by using integration by parts. We have log x as well as dx. This dx is considered as algebraic. 1 into dx, we can take this as 1 into dx, 1 into log x dx. This 1 dx is algebraic and L is log. So what we need to do, by highlight rule, see which function comes first, logarithmic or algebraic. Log comes first, that means we will take that function as u. So that means consider u function is equal to log of x. U function is log x. Then what will be dv? dv function is 1 into dx, remaining value. Okay, now what is du? du value is equal to differentiation of this, that is 1 by x. 1 by x dx. And what is dv integral is v. So integral dv will be v, that is equal to x. Now what is the formula? Integral of u dv is equal to uv minus integral v du. That means integral of log x dx is equal to integral of log x dx is equal to first value is u, that is log x into v, that is x. So it will be x log x minus integral of v, that is x, into du, that is 1 by x dx. 1 by x dx. So these two will get cancelled. So what is the final answer? Here we will get x log x minus of 1 dx, that will be x plus constant. So final answer is x log x minus x plus constant. So this integration of log x is obtained by integration by parts. So final answer, integral log x is equal to x log x minus x. X log x minus x. If there is no other function given, choose this dx as dv. That is it. It is 1 into dx, that is algebraic. Okay. Next is integral of cos inverse x. Integral cos inverse x. Again, here only we have one function, so we will take dx as algebraic and this cos inverse x as inverse trigonometry. We can discuss the solution. First we will solve. Okay, now what is u function? By using isolate rule, which function comes first? This is inverse trigonometry, so obviously first function is cos inverse x. Now what is dv? dv is remaining, that is 1 into dx. That means from this we can write du will be equal to differentiation of cos inverse x minus 1 by square root of 1 minus x square, and integration of dv, that is v. Integral dv is v, that is equal to x. Then what we get? Formula is integral u dv is equal to u into v minus integral v du. Okay, u is cos inverse x, v is x. So we will get x into cos inverse x minus integral of v is x into du, that is minus 1 by, so we will get x by square root of 1 minus x square dx. Now we can integrate this. First function is okay. Second integration is, if we differentiate this term, we will get minus 2x. That means multiply and divide by minus 2. So that means this is of the form dt by root t. This value will become dt. This value is t. So this is of the form dt by root t. What is the answer? 2 root t. So final integration is, this is equal to x into cos inverse x minus of 1 by 2 into 1 by 2 into 2 root t, that is 2 root 1 minus x square plus constant. 2 will get cancelled. We will get this final answer is x into cos inverse x minus square root of 1 minus x square plus constant of integration. You see? So cos inverse x into 1 dx, we will take this function as u, first function into second function. First function into integral of second function minus integral of differentiation of first function into integration of second function dx. So final answer is, this is of the form du by root u, dt by root t, answer is 2 root t. So this 2 will get cancelled, x cos inverse x minus square root of 1 minus x square plus c. Okay, next question is integration of x into cos inverse x dx. Now this question is again similar to previous question. We can discuss the solution directly now. Integration of x into cos inverse x. What is the first function? Cos inverse, obviously inverse trigonometry is first, into integration of second, that is x dx, minus integration of differentiation of cos inverse x into integration of x dx. So what is the answer? This is equal to cos inverse x into integral x is x square by 2. So x square by 2 cos inverse x minus of integral of differentiation of cos is minus 1 by root of 1 minus x square into integral x is x square by 2 dx. Okay. Now what do we get? X square cos inverse x by 2 is first term, that is as it is, minus, we can take this 2 outside, we will get minus 1 by 2 into minus x square by square root of 1 minus x square. Okay, sir. Now what we need to do? Simplify, make this term into simpler. We can divide this, so convert this expression in the numerator into term so that it is manipulated into standard integral forms. So that means we can write this minus half into integral of, we can add and subtract by 1, That means we will get the denominator in the numerator. So that means when we add 1 minus x square divided by root of 1 minus x square. This term will be root of 1 minus x square minus of, we will have 1. So 1 by square root of 1 minus x square. We can split this into two separate integrals. It will be easier to integrate them. So our purpose is to make the denominator bring it into numerator. Try to manipulate the numerator in such form. So we will get first is as it is minus half of integral of 1 minus x square minus 1. 1 minus 1 will get cancelled. So this will be divided separately and integrated, and 1 by root of 1 minus x square. We can do that separately. So first is as it is minus half into integral of, this will be root of 1 minus x square, x by root x type. Minus into minus will become plus half into integral of 1 by root of 1 minus x square. This is sin inverse x, and we already know the formula, integral of a square minus x square. What is the formula? X by 2 root of plus a square by 2 sin inverse x by a. So we will just apply the formula. This will be x by 2 root of plus a square by 2 sin inverse x by a, where a is 1 here. So first term is as it is minus half of x by 2 root of plus a square by 2, that is 1 by 2 sin inverse x, plus half of sin inverse x plus c. So here we will get minus half into plus half, that will be minus 1 by 4 plus 1 by 2, that will be 1 by 4. So final answer comes out to be this, x square by 2 cos inverse x minus, it is clear now how to integrate, easy. Next, this is very important question. Sometimes proof may be asked. In other times, you just remember, you need to remember the result of this. E power ax into sin bx or e power ax into cos bx. What is the result? I will derive first, we will prove this. First find the formula for this integral of e power ax into cos bx type, e power ax into sin bx type. We will do this question, and you can do the same method for e power ax into cos. Again, this formula is of the type, first the functions are product of two functions, exponential function as well as trigonometric function. So we have by Euler rule, exponential as well as trigonometry is there. So whichever is easier to integrate, we will take that as v function here. So here, as this both are infinite series, we can endlessly differentiate as well as integrate both sin x as well as e power x. Integral e power x is e power x, integral sin x is cos sin. So it will keep on varying between those two. That means we can choose any one of the function as u or v. It does not matter for this case. For now, we will consider this function as dv and this function as u. Now how to solve? U is this one, means u is equal to sin of bx plus c. That means dv will be equal to e power ax dx. This portion will be together dv. Okay, that means du will be equal to, du is equal to, differentiate, that will be cos of bx plus c into b, differentiation of bx plus c dx. Now what will be integral of dv, that is v, that is equal to e power ax divided by a. Okay, now what is the formula? Integral is equal to, I is equal to, let's take this as I, that is equal to u into v, that is v is e power ax by a, e power ax by a into, this is v, into u is sin of bx plus c, sin of bx plus c, minus integral of v into du. What is v? V is e power ax by a into du is differentiation of this is b cos x cos bx plus c cos bx plus c dx. Okay, in this b by a is constant, we can take it outside. This will be e power ax by a into sin of bx plus c, sin of bx plus c, minus of b by a is constant, we can take it outside, minus b by a into integral of e power ax into cos bx plus c dx, cos bx plus c dx. Now again we will apply the same formula. This is again e power ax cos bx type. So this function will be dv and this function will be u. That means let's take this as I1. Now what is the value of I1? Okay, what is the value of I1? I1 will be equal to u into v. First we will find what is u. We already know u. That means du will be equal to differentiation of this, that is minus b sin bx plus c dx, and v will be equal to e power ax by a. Now we will substitute here. So what is the formula? U into v. I1 will be u is cos bx plus c into v is e power ax by a into u is cos of bx plus c minus integral of v into du. So v is e power ax by a into du is minus b, so it will be plus b sin of bx plus c okay, dx. So that means this will be equal to e power ax by a cos of bx plus c. Here b by a is constant, we can take it as b by a into integral of, we will get e power ax sin bx, that is the question, which is nothing but I. So this is e power ax sin bx plus c dx. So this is nothing but, so finally we will get I is equal to, we can write now directly, I will be equal to e power ax by a sin of bx plus c, e power ax by a sin of bx plus c minus of b by a into this value, minus of b by a into integral of, that is I1 will be equal to e power ax by a into cos bx plus c plus b by a into I. Now we can simplify this. This is equal to, we can take this minus b square by a square, I will be there. This is e power ax. We can multiply and divide by a here. Then we will get by a square into a sin bx plus c minus of b by a square e power ax cos of bx plus c minus b square by a square I. That means I is, you can take I terms to one side, then we will get I 1 plus b square by a square, 1 plus b square by a square into I is equal to, Here a square is common. 1 by a square into e power ax is also common. So we can write e power ax. We can write this as e power ax divided by a square into remaining term will be e power x by a square is common. Remaining a sin bx plus c, minus of e power ax is outside by a square is also outside. Remaining b cos bx plus c, So what is the final answer? Simplify this also. We will get a square plus b square divided by a square. So we can write this as a square plus b square divided by a square. A square will get cancelled. So finally, what is the integral value? I is equal to e power ax. This a square plus b square will go to the other side, divided by a square plus b square, e power ax by a square plus b square into a sin bx minus b cos bx. A sin bx plus c minus b cos bx plus c. You should remember this result. What is integration of e power ax into a sin bx? Type instead of plus c, if you have just bx also, formula is same, e power ax into sin bx. Then answer will be e power ax divided by a square plus b square into a sin bx minus b cos bx. Similarly, for cos, we can do for cos in the same fashion. Now we will see the solution. I function is this one. Apply integration by parts. Choose this function as dv and this function as u. Then again we have to apply another integration by parts for this. So finally simplify. Answer will be here 1 plus d square by a square divided by this value. So a square will get cancelled here. Remaining term will be as it is. So what is the final answer? I is equal to e power ax by a square plus b square into a sin bx plus c minus b cos bx plus c. In the same way we can do for other e power ax into cos bx plus c dx integration. It is the same procedure. We can directly go through the result. So everything will be same as previous question. Just choose the first and second functions and do this yourself. Take this question as homework. So final answer comes out to be e power ax by a square plus b square into a cos bx plus b sin bx. You should remember these results. E power ax sin bx differentiation integration is e power ax by a square plus b square into a sin minus b cos. Here a cos plus b sin, that is the difference. E power ax cos bx integration is a cos plus b sin. E power ax by a square plus b square is same term. Okay students, with this we will end this session and we will continue with the definite integration in the next session. And always remember to keep learning and keep growing students. Success is yours line by line. Endigu endendigu namma tapasya.